Let's talk about the types of signals and their bandwidth. So for a voice signal, that into brackets speech for telephony, the frequency range is 3000 to 3400 Hz. So the bandwidth is going to be 3100 Hz. For musical signals, the frequency range is 20 to 15,000 Hz. So you subtract and you get 14,980 Hz. For TV signals, the frequency range is 0 to 5 megahertz. So that one too, you just have the bandwidth as 5,000 megahertz. And then for digital signals, for digital data, which is using a telephone line, we are going to have the frequency range be 3,000 to 300 with 3,400 Hz. So the bandwidth will be 3,100 Hz, which is simple to understand. So first of all, modulation is like sending a message using a powerful voice into brackets the carrier signal to make sure it reaches far distances clearly. The key point here is the information signal, which is a low frequency signal. This is the original message you want to send. This could be your voice, a video, or digital data, and it is called the modulating signal. The next thing we have is the carrier signal. This is like the powerful voice used to send the message. It is a high frequency signal, usually in the form of a sine wave. So the modulation process mixes the information signal with the carrier signal. This is done by varying certain characteristics of the carrier signal, like amplitude, frequency, or phase, according to the information signal. The result is a modulated signal that can travel long distances more effectively. So the carrier signal's voltage time variation is given by the equation Vc of t is equal to of a sin omega c t plus um I believe that is phi or delta. Here A is the amplitude, omega c is the angular frequency of the carrier, and phi is the phase. Then we go on to the block diagram explanation. So for the block diagram shows the information signal M of t and the carrier signal C of t being input into a modulator. As you can see there, the modulator combines them to produce a modulated signal which can then be transmitted. So in summary, modulation is the process of using a high frequency signal into brackets a carrier to carry the original information, which is a low frequency signal, over long distances by mixing them together. This allows the information to be transmitted more efficiently and clearly. Modulation. Modul- Modulation. The modulation process simply involves performing an operation on M of t to translate its frequency spectrum to a frequency band suitable for propagation over the available physical channel and its specified frequency, where this is M of t. M of t. Right? So how I'm going to talk about it is, imagine you want to send a message using a toy car, but the message is too big to fit into the car. So you pack the message into a smaller box that fits into the car. This way you can send the message using the toy car suitable frequency band over a track, which is the physical channel. The opposite process of modulation is called demodulation, which is the process of removing the carrier from the modulated signal. When the toy car with the message box reaches the end, You take the box out of the car to get your message back. This is done so as to recover the original information. You open the box, remove the carrier you open the box, which I also call removing the carrier, to see the original message you packed inside. So in simple terms, modulation, packing your message into a box to send it using a toy car on a track, and demodulation is taking the box out of the toy car at the other end to get your message back.